Welcome to lesson 2 in economics, where we're going to look at revenue analysis. We're also going to look at optimization. We'll also look at some calculus. So predominantly, you must understand that economics is not only about graphs, it's also about understanding how to differentiate. So we're going to look at the basics of calculus, then we apply them in revenue analysis. So if we're looking at the power rule in calculus, we're going to look at dy dx. So if you're given a function a, y is equal to ax, and this means you're differentiating dy over the x, because there's y this side and there's x this side. So you can multiply the power n times a, and you subtract a 1 from the exponent. So in this case, if you have y is equal to 5x to the power 4, so this is equal to y over the x, and we're going to multiply the numbers there, 5 times 4. We're going to subtract 1 from the x, 4 minus 1. So what we're going to have is 20x3. All right. Then when you are differentiating a constant,
Mr. Collins,
power 5, yes, please.
which course is this?
Economics. So when you're differentiating a constant, dy dx, whenever the constant doesn't have a letter, it's a constant, it gives you 0. So that is all we need to know about differentiation. So now let's try to actualize them. Suppose you're given u is equal to 10x3. Can somebody help differentiate? What do we get when you differentiate u is equal to 10x3? Du over the what? The x. Okay. So it's called the magnitude of x. So let's differentiate what we have at the end. The u over the x. So we're going to multiply the number. So we're going to have what? 3 times 10, which is 30. So we're going to have 30x what? x2. That's how we differentiate. If you're differentiating total revenue, which we denote as TR, is equal to 10 Q minus 5 Q3. How do we differentiate this? It will be d TR over the what? The letter on the other side is Q, the Q. Whenever we differentiate total revenue, it's called marginal revenue. So this is MR. What happens at 10Q? It becomes 10. How does it become 10? Because it's a 1 there. 1 times 10 is 10. 1 minus 1 is 0. Then the minus 5Q3, when differentiated, it becomes what? 15Q what? Q2. 3 times 15 minus 5 minus, it is negative 15. Then subtract 1 from the 3. It will be what? A 2. So if we have a total cost function, which for instance is given by 40 plus 50Q plus 5Q squared. So total revenue becomes marginal revenue. Total cost becomes marginal cost. So when you differentiate this, the TR over the Q, the TC, sorry, over the Q, what does it become? Marginal cost. So let's differentiate them individually. The 40 is a constant, so it will do what? 4 out. 50q, and differentiate it, it is 50. 5q squared, when differentiated, it will be 10q. That is how we differentiate this function. All right. Let's try to differentiate the profit. We're given the profit, which comes in terms of pi. You have maybe 1/3 q to the power 3 minus 5q squared plus 15q minus 10. So when you differentiate the profit, is the pi over the what? And later on the right hand side is what? Q. The pi over the q. So when you differentiate 1/3 of q, it is 1. We never write 1. 1 is invisible. And you subtract a 1 from the 3, we're going to get a 2. Then 5q to the power 2, we're going to get 10q. Then 15q, when differentiated, we're simply going to get a 15. What happens to the 10? The 10 drops out. So firstly, you need to understand how the process of differentiation goes. All right. So I'll give you these numbers. I just want you to differentiate them. Give me the derivatives. 1/2 q2 q to the power half 4 q5. Let's differentiate them. Give me the derivatives. The first one, q4, what does it become? Fred, when differentiate q4, what does it become? Becomes 4q3. Because it's an invisible.
4q to the power 3.
All right.
4q to the power 3.
Yes. How about 5q minus 3? What do we get? Minus 15q minus 4. How about half q2? What do we get? Simply get q, because half times 2 is 1. We never write it. 2 minus 1 is 1. How about q half? What do we get? We're going to get half q minus half. Because there's a 1 there. 1 times half is half. Half minus 1 is negative half. How about 4q5? What do we get? 20q what? 20q4. Okay. Are we understanding what we've done so far?
No, Mr. Collins.
We're just using the power rule here. There's a 1 there. We're differentiating. 4 times 1 is 4. And subtract 1 from the power here. 4 minus 1 is 3. That's how you differentiate. Then here, 5 times negative 3 is negative 15. Then subtract 1 there. Minus 3 minus 1 is minus 4. Here, 2 times half is 1. We never write 1. 2 minus 1, there's a 1 there, which is invisible. Then half times 1 is half. Half minus 1 is negative half. 5 times 4 is 20. Then subtract 1 from the 5, we get a 4. That's how we differentiate. Is that clear?
Sorry, Mr. Collins, how did we get negative 4 on 5?
Negative 3 minus 1 indices. So
negative 3
minus 1 is negative 4.
Okay.
I want you to get used to this. It's very important. Let's try again. Yeah, 5Q5, 10X, 10, 100X, 4, 100X, 10X half, 3Q3, 4Q4. Quickly help me. Once you get this in, you've done half of my work for today. What is 5Q5? This 5Q5? 25Q4. What is 10X? 10. What is 10? Constant? 0. What is 100X for?
Let me try. 400x to the power 3.
Good. 10X half? (5x minus half). Because half minus 1 is negative half. 3Q3, who wants to try?
I can try. 9.
Q
9Q to the power 2.
Correct. How about 4Q?
4
Q
4Q.
That's 4, because there's a 1 there. 4 times 1
Oh,
is 4. 1 minus 1 is 0, so this Q comes out. How about
okay.
4 alone? What does it become?
0.
0. Why? It's a constant. Correct. So the formulas now you need to understand that when we are dealing with optimization, we are actually actualizing the formulas in calculus. So total revenue is given by TR is equal to price times quantity. Anything divided by quantity is average. So TR, when you divide it by quantity, we can call it average what? Revenue. Then when you differentiate the TR over Q, so the change in total revenue over change in quantity is called the what? Marginal revenue. So we call this a revenue analysis. So let's apply just these formulas before I go verify. Suppose you're given the price is what? 10 minus 2Q. Let's find the total revenue. 100 minus 2Q, sorry. So total revenue is given by what? Price times quantity. The price we're given as what? 100 minus 2Q. So you put 100 minus 2Q. We are, however, not given the Q, we just impute it. So this is under the price, 10 times quantity, we just put it out at the Q. Then we expand 100 times Q is 100Q. 2Q times Q is what? 2Q squared. So this is what we call our total revenue. All together. Then to find the marginal revenue, we differentiate the TR over the Q. It is called what? Our marginal revenue. So when you differentiate 100Q, what does it become? 100Q becomes 100. 2Q2, when differentiated, what does it become? Becomes 4Q. And when you divide the total revenue over the quantity, the name becomes average revenue. Anything divided by quantity is called average. So here we're going to divide 100 Q minus 2Q squared. So we divide each one of them here. So here we're going to have what? 100 minus 2Q. Can identify this one to be similar to the price. So this is our average revenue. Now to optimize, we are actually maximizing revenue. So when you get the margin revenue to 0, we are finding the output and the price are to maximize your revenue. So when MR is equal to 0, what is our MR? 100 minus 4Q. So we're going to solve for Q. Whenever we're being asked to find the output, they're actually asking us to solve for quantity. So when the 4 goes this side, it will be a positive. And you divide the 4 into 100. So we're going to have our quantity as 25. So 25 is what? Output that maximizes revenue. So how do you optimize revenue? We first find the marginal revenue and we put it to 0. Then when we solve for Q, we substitute into the price function that we had. Our price function was 100 minus 2Q. So since we found our Q as 25, we substitute to also find the price. So in the quantity, we're going to put our 25. 25 times 2 is 50. 50 from 100, we're going to have a 50. So we have our optimal points. To maximize revenue, price must be 50. To optimize our output, quantity must be what? 25 units. So let's try question. Suppose we're given an inverse demand function, which is given by 10 minus 2Q. How do you find the total revenue? Who wants to try? How do you find the total revenue? Total revenue is equal to what? Price times quantity. And what is our price? Let's see somewhere. Price is given there as 10 minus what?
That's 2Q.
10 minus 2Q, but we're not given quantity. So what we do? Just impute it. Then we expand. 10 times Q, then Q. Then 2Q times Q, we're going to get 2Q squared. So this is called our total revenue. How do we find our margin revenue? We differentiate the total revenue, the TR, with respect to quantity over the Q. So we're going to differentiate. When you differentiate 10Q, what does it become? 10. 2Q squared, when differentiated, what does it become? Minus 4Q. All right. Then how do we maximize revenue? Maximum revenue occurs when margin revenue is equal to 0. So when you equate this to 0, we're going to say 10 minus 4Q is equal to 0. Then we put the 4Q on the other side, become positive. Then we equate the 4Q to 10. And we divide both sides by 4. Meaning the quantity in this regard becomes what? 2.5. So this is a 2.5 that you put back in the original price function so that we calculate the price also. So 10 minus what? 2Q. But it's Q, put 2.5. 2.5 times 2 will give you a 5. 5 when you subtract it from 10 will give you 5. So this is how we optimize revenue. Revenue optimization. So sometimes you'll be given the function of the demand in terms of the direct demand. For instance, Q is equal to 20 minus 2P. So it's advisable that you do what? You can put 20 minus 0.5P. It's advisable that you do what? You make P subject to a formula. We call that the inverse demand. So when this one comes this side, you're going to have 0.5P is equal to 20 minus what? Q. We just swap to this one, has come this side. If a negative, this one has come this side to be a positive. There's an invisible one there. So to make P subject, we divide both sides by 0.5. Individually, just divide throughout by 0.5, 0.5, even here 0.5. So meaning we're going to have our P this side alone. And here we're going to have 40 minus 2Q. Can you get me? Am I audible? Ms. Amawa, can you hear me?
Yes, I can get you.
Are you following through?
Yes, sir.
All right, so when you're given the function in terms of Q, make P subject a formula. So when this one comes aside and this one goes aside, and then you divide 0.5 on both sides, you're going to get P is equal to 40 minus what? 2Q. It is at this point where you can now start to calculate the total revenue, which is given by price times quantity. So in this case, price times quantity, we're going to say 40 minus 2Q. And where there's Q outside there, we impute the Q. So we're going to have our total revenue to be 40Q minus what? 2Q squared. So this is our total revenue function. So to differentiate it, we're going to set the TR over the what? The Q. So we're going to differentiate individually. So 40Q is equal to 40 minus 2Q squared is equal to 4Q. So how do we maximize revenue? When we get the margin revenue to 0. So R is optimized. Our total revenue is optimized when we equate the MR to 0. So 40 minus 4Q. We make Q subject. So when Q is made subject, we're going to now solve for Q. So divide both sides by 4. So meaning our Q, therefore, if you solve it, will be what? 10. So if Q is 10, that is the output in terms of units. What is our price? So where there is Q, put a 10. So this is 40 minus 2 times 10. So 40 minus 20, which will give us a 20. So this is how we optimize. This is called optimization. We also have what is called the cost theory. Cost is simply a combination of two types of costs. We have our total cost, which is equal to the total fixed cost plus the total variable cost. So what are fixed costs and what are variable costs? Fixed costs are costs so we need to understand what our costs are under cost theory, define what variable costs are, and also understand how the curves go. So what is total cost? And how do you compute the variable costs and the fixed costs? And how do we interpret an equation? What are some of the examples of variable costs that we have in an organization? So it is important to understand that when we're optimizing, it is costs that are minimized. Most people think when you hear the word optimize, always maximize. It's not necessarily the same when we're dealing with cost theory. Okay, so under theory of costs, I have this to say. So to start with, we must understand that in economics, cost theory refers to analyzing and understanding the various costs that are involved when you're producing goods and services. We actually want to examine what relationship exists between the units that we use in production and the incurred costs that suppliers or producers incur. And so cost theory is very crucial for firms that are in production so they could make decisions on how to set prices and to maximize profit. So the different types of costs that you must understand. We have what we call the fixed costs. These are expenses that don't change with the level of production in the short run. These ones are incurred regardless of what output we produce. Some of the examples of fixed costs are rentals, salaries, insurance. We need to pay them regardless of what you are producing. And variable costs are simply expenses that vary with the level of production. They will increase as we increase production, decrease as we decrease production. Examples include the raw materials, direct labor, and utilities. So when you sum up the fixed cost and the variable cost, we call it the total cost. Mathematically, it is given by TC is equal to FC plus VC. We also have other costs that we would be interested in, and these costs are called average costs. We have average total cost, average fixed cost, and finally we have the marginal costs. So we need to understand these costs in their context before we go into the computations. So what are the average variable costs or average total costs? Average total costs are calculated by dividing all total costs by the quantity or output produced. The average costs provide insight into the cost per unit of production and help the firm assess the efficiency. So there are different types of average costs. So we have the average fixed cost, which we obtain by dividing the total fixed cost by the quantity. We also have the average variable cost, which we obtain by dividing the average variable cost by the quantity. And the average total cost, which we get by dividing the total cost by the quantity. Marginal costs refers to the additional units that we incur when producing one additional unit of an output. It is the change in total cost over the change in quantity. And marginal cost is also very important for firms because it helps them determine the optimal production level. So when we have a function, for instance, of total cost is equal to 100 minus 50Q squared plus 50Q. So in this context, what is our fixed cost? The fixed cost is a constant part of this. So we say that the total cost is simply a combination of what? Fixed cost plus variable cost. So which ones are fixed cost? The constant part. So this constant part there is called a fixed cost. So our fixed cost is 100. And average fixed cost, we just divide what? Total fixed cost divided by quantity. So when we divide our total fixed cost, which is 100, we divide it by the quantity, we're going to simply remain with 100 over quantity. Our average fixed cost is a part that has letters. So this whole part here is called the average. So here we're going to have minus 5q squared plus 50q. That is called our average variable cost. It's called the variable cost. We didn't divide by quantity. It's just the total variable cost. So to get the average variable cost, we divide the total variable cost divided by quantity. To get the average fixed cost, we divide the total fixed cost divided by quantity. So our average here is minus 5q squared plus 50q. So when you divide both sides by q, we're going to have our average variable cost. So average variable cost will be minus 5q, since 1q has cancelled, plus 50q. Q cancels, you're just going to remain with the 50. Then marginal cost, who remembers? We differentiate the total cost over the quantity. This is called our marginal cost. So when we differentiate this whole function from our calculus, which we learned, what happens is 100, it's a constant, it drops out. Minus 5q squared, what do we get? We get minus 10q. Then the plus 50q becomes 50. So to optimize costs, we must equate the marginal cost to 0. To optimize costs are minimized, revenues are maximized. So when this comes aside, to be a positive quantity, 10 is equal to 50. Then we divide both sides by 10. We're going to have our Q is equal to 5. So that is how we minimize costs. So what is our takeaway from what we've explained so far? We've explained to say total revenue. Who can remember what's the formula of total revenue? Price times what? Quantity. Average revenue is found by what? Total revenue over what? Quantity. Marginal revenue is given by change in total revenue over the change in quantity. If you're using calculus, it is dTR over what? dQ. So this is how revenue analysis is done. Then the total cost, what have we said? Total cost is given by the total fixed cost plus the total variable cost. So when you differentiate the total cost over the quantity, we call that the marginal cost. And when you divide the total cost over quantity, how do we call this? The average total cost. Anything divided by quantity is called average. Remember here, total revenue over quantity is average revenue. So it therefore follows that the total fixed cost, if we divide it by quantity, what does it become? The T just changes into an A to the average fixed cost. How about if we divide the total variable cost over quantity? What becomes of the T? It also changes, becomes our average variable cost. So graphically, our total fixed cost is downsloping. Our average total cost is U-shaped. Then our marginal cost cuts into our average total cost. So this is how cost graphs look like. if you want to learn basic economics. So this is how the graphical cost theory looks like. Okay. So you'd be given a function now. For instance, price is equal to 170 minus what? 5Q. You're given the total cost as 40 plus 50Q plus 5Q squared. You're told to find 10 things. Number one, find the total revenue. Number two, find the margin revenue. Number three, find the average revenue. Number four, maximum revenue. Number five, I have to find the total fixed cost. Number six, total variable cost. Number seven, average variable costs, fixed cost. Number eight, average variable cost. Number nine, the marginal cost. Number 10, the profit. So let's try to find each of these 10 marks. So who remembers the total revenue? How do you find total revenue? Price times quantity. So what's our price? 170 minus what? 5Q. The quantity we are not given, we imputed. So Q there. So what becomes our total revenue? 170Q minus 5Q squared. Are we together? Are we clear on the total revenue? Are we together on the total revenue?
Yes, we are.
All right.
No, each tamunga, but we are there.
So how do you find the marginal revenue? We differentiate the total revenue. So DTR over what? DQ. So in this case, 170Q becomes what? 170. 5Q squared becomes what? 10Q. Differentiate that. Then average revenue, what is the formula? We divide the total revenue over what? Quantity. And in this case, our total revenue was what? 170Q minus 5Q squared. So we divide individually over Q over Q. So what do we get? We're going to have 170 minus what? 5Q. So this is how we find our average revenue. To maximize revenue, we equate the marginal revenue to 0. To minimize cost, we equate the marginal cost to 0. Maximize profit, we equate the marginal profit to 0. Anything marginal equated to 0, we are optimizing. So when we take this side, we're going to have 170 is equal to 10Q. So we divide both sides by what? 10. And our Q will be 17. So we're going to substitute the 17 back into the price function, which will give us our price as 85. So here, put 17 to be 170 minus 85, which is 85. So this is how we optimize the revenues. Then we go to the total fixed costs. So since this is our total cost function, we can easily identify the fixed cost and the variable costs just by looking. So what is our total fixed cost? The constant part of it. So here we're going to have what? 40. What is the total variable cost? It is 50Q plus what? Anything that has a lid is variable, is affected by output from our definition, 5Q squared. And how do we find the marginal cost? We differentiate this function. The 44s, so we're going to have 50 plus 10Q. How do we find the average fixed cost? We divide the total fixed cost by quantity. So our total fixed cost was what? 40. We divide by quantity, we just remain as 40 over quantity. Can't simplify any further. And how do we find the average variable cost? We divide the total variable cost over quantity. So in this case, we're going to have 50Q divided by Q plus 5Q squared divided by what? Q. So here we're going to have what? 50 plus 5Q. That is how we find our average variable cost. And lastly, to find the profit, we simply subtract the total revenue minus total cost. So profit is the difference between the revenues we're making and the costs we're incurring. Graphically, you're going to see marginal revenue looks like this. Total cost looks like that. Total revenue looks like that. The point at which total revenue meets with revenue, total revenue and total cost meet, we call these ones a break-even point. So if here we have 3 and 7, we're breaking even. So this break-even point is the point at which our profit is equal to 0. So we can advise the firm not to produce anything less than 3 units or anything more than, because our profit is in between that range. More than 7 units, we're making a loss. This is negative profit. And less than 3, we're also making a loss, which is a negative profit. But between 3 and 7, we call that our profit margin. So whenever total revenue is greater than total cost, we are always making a profit. So we've been given the formula, a profit, which is denoted by pi, is total revenue minus total cost. So we calculated our total revenue already as 170Q minus 5Q squared. And our total cost was given, we put it in brackets, it's 40 plus 50Q plus 5Q squared. Now be careful with the brackets, because this negative here will negate everything that is positive in the brackets. So our profit in this case will therefore be what? 170 minus 5Q squared minus 5 minus 40 minus 50Q minus 5Q squared. So we put the like terms together. So this is 170 minus 50Q minus 5Q squared minus 5Q minus 40. So we evaluate now. So this will give us 120Q minus 10Q squared minus 40. So this now becomes our profit function. So now to maximize profit, we differentiate the pi over the Q. We call this a marginal profit. So marginal profit here will therefore be 120Q becomes 120. 10Q squared becomes 20Q. What happens to the 40? it drops out. So when you get this to 0, the 20Q will go on the other side. So you're going to have 120 is equal to 20Q. So 20Q, we divide 20 on both sides. So we're going to now have our Q is equal to what? 6. So 6 units will maximize profit. So since our price was given as 170 minus 5Q, you can also calculate the price to maximize the profit. So if we put our 6 there, we're going to have 170 minus 30. Because 5 times 6 is 30. So the price to maximize our profit will therefore be 140. So this is how you get your 20 max under optimization. And so your homework therefore will be to calculate everything I've done, except that I'll change the figures here. I'll ask you to half them. Price here is equal to 85 minus 2.5 Q. The total cost, I also half it. Where there is 40, I put 20. Where there is 50, I put 25. And where there is 5Q, I'll put 1.5Q squared. So I want you to try everything I've done under this function as your homework. I require of it tomorrow. Okay, so we've done optimization, calculus, and revenue analysis. So this is where we end. So those of you who are still behind, we have done 6 topics so far. So please inbox me on this number for private arrangements or the class arrangements that we're having. And also get to get the videos of the classes we've had already. By weekend, we should be done with the whole syllabus, and we start going through exam papers. So yesterday, we looked at demand theory, and we concluded, looked at supply theory. We looked at also elasticity. Today, we have done revenue analysis. We started with calculus, and done revenue analysis and optimization. To optimize, to find the maximum, to maximize, in short, or minimize revenue. Now, optimization is wide. It will almost cover most of other topics, even under production theory. We'll look at optimization. So if there are any questions, you can ask now.